Diffraction is a wave property of light. And if you think back to mechanical waves, such as sound, when somebody's on one side of a doorway and you're on the other side of the doorway, if they're talking, you can hear them even standing very close to the doorway off to the side. So those sound waves spread. Light is going to do the same thing, and becomes more obvious when the slit that it's going through is about the same size or a small multiple of the wavelength of the light. This comes out of Huygens principle, where any point on a wave can have an infinite number of point sources for new wavelets, if you remember that. And so those wavelets interfere with each other and cause constructive and destructive interference, and that will cause the bright and dark pattern on a screen on the other side of that slit. We have an equation for the destructive interference where d is the width of the space, and sine theta is the angle that the bent ray makes with the original ray, so you can think of it like the bent ray to a normal line. And then m is going to give you the order of the minimum. Remember, we're talking minimums now. So there's instances where you would have double slit, triple slit, quadruple slit, and then lots and lots of slits for a diffraction grating. And there is diffraction and interference if the size of the slits are just right in a double slit experiment, and does exactly what you would expect. The waves superimpose, and you end up with an increasing brighter and brighter as you move towards the center, and then back away from the center it gets less and less intense, but you have fringes in between. So we talked about, the idea that there's a single slit and a double slit and triple slit, and then it goes on to create a diffraction grating. So a diffraction grating is basically a slide that has a lot of lines on it that cause the light to diffract. So it'll have the equation is d sine theta is equal to the order times the wavelength. Once again, d is the distance between each of the slits. And so you gotta be careful. Are we talking about d as the width of a slit, or d the distance between the slits? So be careful when you're solving problems to be sure which equation to use and what you're looking for. And then theta is still the angle that the light's bent from the normal. One of the applications of diffraction is X-ray diffraction, which is used to find the location of atoms and molecules. Basically, you fire the X-rays at a crystal, and then the pattern shows up, and it's generally a pattern of dots. It's kind of an interesting picture. It's not what you would imagine. There are bright spots and dark areas. And the geometry of this can be described with what's called the Bragg equation, which looks a little different than the other interference and diffraction equations because the light is going into the crystal and out of the crystal, which gives you twice the path, or 2D is what we're looking at. It's going in between the crystal pattern on one side and coming back out. So you have m lambda is 2D sine theta, where m is going to be the order of the light, and then lambda is the wavelength, 2D is the path length, and then sine theta, it's a little different than reflection. It's going to be the angle with respect to the surface, not the normal. So this you'll have to draw out like a lot of the other optics. Make sure you're labeling everything correctly, and you're measuring the angles from the right reference points. All right, good luck. Bye-bye.